Hi, everyone. My name is Divya Ashok. Before we get started with our whole presentation, how many of you are architects or system integrators or basically on the IT side of the house? Awesome, a good number of you. And are others on the business side? You work directly with customers? Okay, so just to set a few expectations, what we're trying to do here is you're going to leave this session not as an expert on machine learning or big data. However, what you are going to leave with is the ability to lead a project at your own firms around big data and machine learning. So we're going to equip you with all the tools that you will need to get yourselves to start leading a project out there. Okay, before we go any further, I'll quickly introduce myself. Like I said, my name is Divya Ashok. I am a director of product management at Salesforce. I've been here about 7.5 years and donned multiple roles, the most recent of which is product management. Archana?
Thank you, Divya. I'm Archana Seturaman. I've been with Salesforce for the last 5.5 years. Like Divya, I've done multiple roles as well. Started out as a developer, moved on to be an architect, and more recently, taken on a fascinating role of performance engineer within the enterprise scale team.
Awesome. So what are we going to walk you through today? Before everything, all of you must be by heart with this right now. So all that we have is forward-looking, so please do not make any purchasing decisions based on that. Today, we're going to talk to you about our challenges. We have customers who face integration challenges day in, day out. We work with some of the largest customers in our team, and this is something that affects anybody and everybody of any size. So we're going to talk to you a little bit about that, set the context, and then we're going to walk you through big data, machine learning, and also what are those considerations that you need to be making when you are going out there and trying your own big data projects. All right. So what happens today? As a product manager, I continuously get two types of questions. If I'm talking to a business user, then they're thinking about efficiency. They're trying to figure out how soon will I be able to get back to something? How soon will I be able to load my data into Salesforce so that I don't have to worry about managing two different systems? Any sales managers in the audience? No, but if you could imagine for a second, a sales manager is on a forecasting call. If they have two different systems and their team tells them two different numbers, it's pretty bad for the company that they're in. So most business users think, one system, I just want to deal with one set of things, easy, efficient, simple. That's all they're thinking about. On the other hand, for the architects in the room, for the folks in IT, when you're thinking about system integration, the constant question that we keep getting is, how long is something going to take? We at Salesforce are a multi-tenant platform. So there's questions about, can another customer impact me? And there's also other questions, right? You're always thinking about, wait, is this customer's load too big? Is the type of data that they're going to be loading a problem? How many systems do I have to integrate? What are breaking points? All of those are key considerations. And we want to have an easy answer. Unfortunately today, that is not the case. And why is that? Traditional methods don't work. Now we have our cell phones, we have IoT, as you've seen in all other presentations. We find that it's very hard in today's world to get large amounts of data to be computed efficiently. I know my team works on this stuff all the time, and they end up amassing huge amounts of data, and it just gets very hard to crunch. Moreover, you remember how we talked about every customer is different. So it's very hard for them to take the same set of data and repeat it. Imagine, would you like healthcare data and you go tell a bank, oh yeah, totally, everything will work for you, your systems are going to work fine. Not possible today. So we'll show you a quick scenario, and we'll walk you through the considerations and everything else from there. So I'm going to play Dinah, who's the VP of Sales.
And I'm going to play Alice, who's the IT architect.
So imagine this. I'm on the East Coast in the morning. I have a forecasting call later today, and I have a management update that I need to make. Hey, Alice, good morning.
Hey, Diana. Good morning. How are you?
Awesome. I know it's pretty early for you, but as you know, we have our quarter end today, and I need to get my forecasting numbers.
Sure, my team has been working over the weekend, and we've been looking at different systems. We're almost there. Things are looking mostly good, but I'll have the final numbers to you out by, say, in about 2 hours. We still need to look at a couple of more systems and crunch through some more numbers before we can get you the final report. There
you go. Sound familiar? Now, as a business user, this is not something that's acceptable to me. A lot of times, I want to have a few hours with my team to review it before I can go to management. So, Alice, is there something that we can do? Because obviously, I don't want your team and you to be losing your weekends, not drinking in Napa, instead working on numbers. That's not fun, right? Why is it that, we can't get this to a better state? I would love to get this to a better state. Can we talk for a few minutes about what my ideal state would be?
Sure, absolutely.
Well, in the ideal world, here's what everybody's morning should look like. Have a great cup of cappuccino, and while I'm thinking through things in the morning, I want to be able to ask somebody like Alexa or Siri or Cortana, because I like to talk. And all I want to ask are simple questions. When will the data loads complete? Snap my finger, and the answer should come right there. I need to be able to ask other things, like when my forecasts are going to be ready. And lo and behold, it shouldn't be a few hours, but instead it'll be ready for my 8 a.m. call in the morning. All I want to say is thank you to Alice and let her sleep.
Yeah, can't wait for the day, where my team can get some good night's sleep.
So let's talk a little bit through this. If we were to make this a reality, how could we go about this, Alice? So before we continue, a few terms. Big data, machine learning, these are things you've heard throughout the industry. You've heard this probably at the conference as well. I simply look at it this way. And Alice, you can correct me. You're the IT person here. So I look at big data as the zillions of data that we will need to crunch, because I'm planning to grow my team. And when we go global, I want to make sure that we can get all those signals in there.
Sure.
Makes sense?
That sounds about right, yeah.
And machine learning, the way I look at it very simplistically is, it's like the age of robos. You need to give the ability to computers to be able to learn without actually programming them too much. Ideal world case. So let's talk a little bit about what are those considerations? What do you need to do to make big data happen? So Alice, can you walk us through a few things we need to be thinking about?
Sure, Diana. The way I look at a big data project is I can divide it into 4 main stages. First comes the planning stage, where you plan for such a big project. And then comes the data collection stage, because big data, we are talking about millions and zillions of data. It's going to be coming in from multiple different sources. So we need to find a way to collect the data and clean it up such that in the analysis phase, we can start working on the data and building our model, which can get us all the predicted values. Finally, in the visualization stage, we can connect it to the device of our choice and let the end users be able to visualize the results.
Sounds fairly simple, but let's dig a little bit deeper. When you say planning, what exactly are you referring to?
So for the planning stage, oftentimes big data projects can be open-ended. By open-ended, I mean it is a huge project, so it's going to take a couple of iterations or a few iterations before you can start seeing the final results and start getting the accuracy that you desire. So it is very critical to make sure you start with a clear goal. And because once you have the goal, you can get your management buy-in and get the folks interested and excited about the advantages of this project and make sure they're all on board. So once you have the management on board, you can then start building a team. Oftentimes, big data project requires some specialized skills like data scientists. But we have a couple of folks in our team who are interested in this technology, so we might be just leveraging them.
Sounds
so building a team is based on the skill set that you have. You might have to recruit new people, or you might have the skill set already. So form a team of, we need to form a team of people that can work on this project. And they're going to be coming up with an architecture model to solve the end-to-end design of this whole project. And based on the architecture needs, we can analyze the hardware and software requirements. Oftentimes, a big data project is going to require a heavy load of hardware and software needs. So this should give us a fair estimate of what we are looking at. So once we have the hardware and software requirements, it's the go time. We'll get the team, start building the model, iterate through them. We'll obviously keep your team in the loop and gather your feedback from time to time and show the progress that we've been making, and we'll get to the end goal. Yeah.
Sounds fantastic. 2 questions though. So of course my team will be able to give you feedback. So it sounds like it's not a one-time thing. It's going to be an iterative process. And that's good to know, because I want to help set management's expectations, and that's very key. But what about the hardware and software? Why should we spend millions of dollars on something that we know may or may not work?
So good question, right? So we can start small. We can start with a POC. We can show you the benefits of a big data project. That way, you can see the vision and where we are heading towards. And then, once you see the benefits, I'm sure both you and your team, as well as the other management folks, would be more than interested in investing in this technology.
Sounds great. So now that we have a plan, or we know how to get a plan in place, you talked about data collection. What is that all about?
So do you like Dilbert, Diana?
I love Dilbert.
All right. So there's this Dilbert comic strip, and along the same lines, there is also another saying which goes like, if you keep looking at the data long enough, it's going to confess to whatever you want it to confess. We don't want that, right?
No.
We want the data to tell us the truth. So we want to make sure the data that we are collecting is true, it's clean. So, and for that, we need to come up with the right data sources, because we have multiple different systems with petabytes of data. So we need to narrow down the right systems which can give us the right metric for the problem that we are trying to solve. So first comes the data source. And next, we need to come up with a scheduler. I don't want anybody in my team working overnight, trying to get the latest and greatest information every day. So we're definitely going to need some sort of a scheduler that can run nightly and collect the information and keep updating the data feed that we are building. And once we have the scheduler, then comes the variable selection. If there are a large number of fields that you can work with, there might be 50 or 30 fields that you might be really interested in that might help you solve the right, solve your question. So we need to narrow down the right set of fields that can help us get the answers that we are looking for. And finally comes the data cleansing part. Once you figure out the variables, you need to make sure that the data that we are collecting for these variables are clean. Like in this case, what I mean is if there are null values, or if the values are missing, we need to make sure that we are appending zeros or processing those data and removing any false positives or false negatives out of the data set, such that at the end of all this, we get a very clean data source which can give us the right values.
In our case, though, if my sales team is not putting in the numbers, and if you find any null values, please let me know. I'll get you the right amounts. All right, so now that we have the plan and we have the data, clean data, what's the next step?
The next step comes the analysis stage. So in this stage, once we have the data, you split the data into a training set and a test set. So when you split the data into a training set, that's what you use to build your model and train your model such that it can start giving you the predicted results. And once you have the training model built, you can then use a subset of data that you have collected so far to validate the model and make sure that you're seeing the accurate results, or you are able to analyze the accuracy of the model. So what you can do, typically what people do is split the data into 70% to be used for the training data set, and this remaining 30% to be used as the test data set or the validation data set. So you can see the training camp and test camp that Astro is planning to go to here. And finally, once you've validated the model and you've figured out that you're getting the right accuracy, you can start feeding in brand new data that you want to start predicting against. And you can run the algorithms, and it's going to start giving you the predicted values that you can leverage for your forecasts.
Got it. That sounds fairly easy to do, but quick question. My sales team and I are not as smart as your architects. We need to know how to actually visualize this data, because if it starts coming up in a black screen and starts scrolling through, I'm not going to be able to get it. And if it comes in a large report, we may interpret the wrong numbers. So how can we help visualize it better?
That's the fun part. You get to pick the device that you like. So I know you like Alexa, so we are definitely going to make sure that we have an integration such that Alexa can talk to, there is a way for Alexa to connect with our computed predicted results, and it can give us the predicted values. But we can also come up with a wave dashboard. We can also build a wave dashboard which can be used by a team, such that if they want to look at deeper details into the numbers, they have a way of doing that. And it needn't even be a wave dashboard. We can build a simple web page that can give you the predicted value by just inputting a text field for the less tech-savvy people that might be there in your team.
So let me get this straight. You want us to have a plan together. We'll get the management buy-in. We'll start chunk size. We'll pick at it bite size. We'll get clean data sets. And then you're going to work through an iterative algorithm to make sure that it validates the data, the test data that you were talking about in the training camp that you just mentioned. And then right after that, we should be able to do anything from a simple web page to Wave, which we can take on the go. So my sales team always has its numbers, can be punching it, and it should be able to adapt. Is that right?
Absolutely. Yep. You got it.
Sounds fantastic. When can we get started?
Do you want to see a quick POC of where we are going with it? I know we've heard your visions, in the passing, so we know this is high on your list of things. So we started building a small POC.
Okay.
Before we go any further, to set the context, I know you're looking at your forecasting numbers, but to get there, we need to start taking small baby steps. So.
Sure.
We started with a small problem definition where we wanted your Alexa to answer a simple question like, how long is it going to take to load 60,000 records of account object into Salesforce?
Okay.
So that was the problem statement that we began with. And let's look at the different stages, right? So we talked about the 4 different stages that are needed in a big data project. So in the planning stage, we assembled a team of folks.
Okay.
In this case, we hired an intern, Srinath. He's an awesome intern, and he helped, along with the team, he helped build an architecture design for this entire end-to-end project. Okay. And while building the architecture design as well as coming up with the model, he gathered feedback from the extended circle, and we went through the iterative process that we spoke about.
Awesome.
And once we had the planning phase done, we went into the data collection phase. In the data collection phase, since we are talking about integration logs, integration numbers here, we wanted to find the time taken for a particular integration to complete. We wanted to leverage the integration logs that we were getting from the different data sources. So our data source consisted of our integration logs, as well as the DBCPU metric from another data source. So the reason why we went for getting the DBCPU metric was that we wanted to find out whether the system was, how the system was behaving, whether it was running at peak volumes or whether it was in an idle state. We wanted to see how that affected the overall runtime of our model. And finally, we built a Python scheduler that ran nightly to collect new logs that were coming in every day. That way, we could update our model and we could leverage the latest and greatest information that was available to give us more accurate results.
So then you talked about the analysis phase. I'm sure you've done something.
Exactly. So in the analysis stage, we started with a linear regression model. So we built a linear regression model. We used R language. Since this was a small POC, we were able to utilize R language and linear regression to begin with. And for the training and test data, we collected 1 month's worth of logs from our systems. And out of that 1 month, we used the first 27 days worth of data to be our training data set. And we used the last 3 days worth of data to validate the model and start testing it out. And finally, for the visualization phase, we were able to connect Alexa to this model. And we built a custom skill on top of Alexa that was able to call the predicted value. So we pre-computed the algorithm. We run the algorithm, our algorithm nightly. That way, as and when it starts getting the new logs from our systems, it can run the linear regression model, compute the predictions, and then load the data into a place where Alexa can integrate with it and get the results. We don't want Alexa to be waiting for some long-running machine learning algorithm to run at the backend to get your results. And since we are running it nightly, you are getting the accurate results. So.
That's great. So it's able to adapt very quickly to all the changes that my team would be making.
Definitely.
That's perfect. So that's a good start. That's a great start. Anyone here want to see the demo? All right.
Yeah.
So unfortunately, Dreamforce Wi-Fi is not sufficient for us, for Alexa. She decided to have drinks last night and decided not to work with us. So I'll need your help to get, This is our awesome intern who actually worked on this project.
Hey everyone, I'm Srinath and I'm interning with the enterprise scale team in R&D. And we support top 5 enterprise customers of Salesforce. Our existing customers typically ask us for the time to sync a given volume of data, and we build simulations on simulated orgs to come up with these numbers. And this process might take even up to weeks. Now, using machine learning, we can get the time to sync a given volume of data immediately. Alexa, ask Salesforce for time to sync 80,000 rows of account object.
Sure. Data sync runtimes change based on orgs. Can you please tell me the org name?
Comcast.
Which operation are you planning to perform? Read, insert, or update data?
Update data.
Predicted runtime to update records using patch method in REST API is 2.8 seconds. Prediction accuracy is 94%.
This app was built for REST API, and REST API is used typically for volumes less than 1 million rows, and we use bulk API for larger volumes. Here is a teaser of what's to come for bulk API. Alexa, ask Salesforce for time to sync 2 million rows of account object.
Are you kidding me? Use bulk API for data sync operations with more than 1 million rows.
Hope you guys liked my demo. In case you guys have any questions, please contact Enterprise Scale.
So that was our intern, and like any good PM, I have to have scope creep in there. So that was the bulk API teaser. Let's do a few quick key takeaways. So, and Alice, help me out here. As a team, we need to plan. So that would involve clear, simple milestones, getting our management buy-in, starting small, so don't spend millions of dollars right up front, prove a proof of concept, and then get going from there. Remember, it's an iterative process, and that's key in setting management up and your teams up for success. Data collection, it sounded like we need to have clean data just so the data is not lying to us. And for that, it's very important that we do keep in mind multiple systems that you will need to integrate from. Use a nightly scheduler, unless you love watching Netflix and collecting data on the side. And think about the variables that you want to use. It's not important to have 100 different variables. What is important is to make it robust. So if you're thinking about spikes like holidays, systems may not get used as much, whereas there may be other peak hours. Think about those kinds of things when you are thinking about your model. Anything else on the data collection?
Just make sure the data is not lying to you. That's the mantra.
And then when it comes to the analyze phase, like Alice or Archana pointed out, you do have multiple languages you can choose from today. Start simple. We started with the R and linear regression, given that's something that's simple that an intern was able to pick up quickly and run with. So there are other languages, other models that you can use. Do something that is useful for your data. It is totally dependent on your data and what are the results that you're trying to get out of it. Lastly, visualize phase. We're all humans at the end of the day. We love to see things. So it could be as simple as putting it into a Wave dashboard, hooking it up with an existing web page that your end users use on a daily basis, or sending a quick email for those who want to see it when they're in the train or coming into work. Or like me, you can get Alexa. Idea behind this is, like we said earlier, this should help equip you to lead a project that will not only give you insights into operations, make changes in how you do things, but it should also be something that is repeatable. Like the teaser, we were able to add the bulk API soon after as an additional step. And the net cost for that was far lower than the one that when we started. So as you just keep growing this project, it's just going to become easier. I guess that's pretty much it, and we'll leave a few minutes for question and answers. Please, can you take the mic so everybody can listen?
Have the APIs for both Alexa right now, which is working, and also just you can ask a question and just, let's say I want to run a report rather than just repeating the information. So let's say just, hey, can you run these reports for me as an end user, so I'm just running out of it time, and just I can ask Alexa and then I can continue. After a few minutes it may say it already. And that also works with the Siri also, just only Alexa right now.
So just to make sure I understand your question right, let me replay it. So you're asking if Alexa can just run a report. So instead of asking Alexa the questions, I'm going to say, Alexa, can you pull up my Wave dashboard today?
Yeah, can you run the report, basically, let's say.
Can you run the report? Yes.
Yeah.
We've done that. We did a small, quick demo on the side, internally. It wasn't fully ready yet, but that's fairly easy to do.
Okay.
You should be able to add a skill to do that.
So Alexa comes up with, if you're looking at integrating Alexa with something like this, you can start building custom skills on top of Alexa. And if you're using Salesforce, we provide, Wave provides an API using which you can connect to the different Wave dashboards, and you can make the Alexa custom skill, bring up the report that you want based on whatever input that you're trying to give to the Alexa.
Okay. So does it work only with the Wave, or just does it work with the regular, just if we don't have Wave, for example?
Okay.
So just we have just regular reports. So you can have this, my question is that more of a broader is that, can we use Alexa as an interface rather than typing or doing something?
So Alexa was used here as an interface,
okay.
And that's a good question. You should be able to directly take this and integrate it only with Wave if you need, or reports, or something else. Basically anything that has an API.
So Alexa is just a front end here.
Yeah, yeah.
All the computations or whatever logic that we have built into is in other systems or servers, or you can connect it to Wave, you can connect it to your own reporting engine if that supports in web servers that Alexa can connect to or hook to.
So it's a limitation is at the side of the Alexa APIs, basically.
If it's not a limitation, you can do that. So
Okay.
if whatever you're trying to connect to can support an external call, all Alexa is trying to make at that point is a web service call to another system. So if your web service can pull up the report in whatever form that you want your system, Alexa will be able to do that.
So is it GA right now or not yet?
It's not GA.
This is
It's
not
an
GA.
internal POC.
Okay. So
Yeah.
when do you expect to see that it's GA?
That's a great question. Right now, this is POC. We still have to work through how we work it into Einstein overall, and we'll probably post on the chatter feed for this, whenever we get it, or if you're interested, we can wait a few minutes after and send you a note.
Okay, thank you.
What are the variables that you use for your modeling?
So we used around 30 different metrics. We collected logs from our Splunk, which is our logger, internal logger for the different transactions that happen on top of Salesforce. So we collected logs specific to the REST API, and we used metrics like which org was this particular integration belonged to, which pod the particular integration belonged to, what was the runtime. And if you're aware of performance metrics, we have metrics like buffer gets or DB CPU time, and other times.
Which variable was most predictive?
Sorry?
Which variable was most predictive?
Which variable was most predictive?
So what we used here was we used a step function. So we didn't want to feed the model or influence what we know already as performance engineers to be the most influential variables to the model. So we wanted the model to tell us what are the variables that are mostly highly influential, right? So R comes up with a step function, which is a dynamic function which can select the variables with the topmost priority each time you run the algorithm. So every time the algorithm runs, this function is going to go check against each and every 30 variables as to which one has the highest accuracy, and it's going to apply those variables for predicting the model. So we have the variables. If you're interested offline, I can show you what we did.
And in addition to what she said, I think what we were looking for overall was two things. A, we wanted to know at peak times, do we have an impact? Because our system is multi-tenant, the system that we were working on. So we wanted to know, hey, how much does it impact us if somebody else is trying to do similar data loads or running large transactions on the system? Versus, how much does it impact when the system is low? On a holiday, for example, or early in the morning. So that was kind of where we were looking at, as opposed to specific variables, because there is a ultimate goal as to how can we get our own teams to forecast their numbers well, to predict their forecasts. That's kind of a goal that we set in mind.
So how do you get those metrics from the database? Is that something that's publicly available through an API, or how is that something that we could do?
So what is the problem that you're trying to solve?
So just predicting the database load for the next hour, let's say, and say, I want to figure out if this is a good time to run, or if it would be better to run later on in the day.
So the metrics that we have right now are our internal metrics. So we have an internal logger called Splunk, which logs our transactions in the sense that we get the performance, the runtime for that particular transaction, what was the system metrics like buffer gets, DB CPU times, and so on and so forth. So we leverage those metrics to come up with this model, and it's an internal only logging mechanism. So we are leveraging that to come up with this particular question. But if once we build this, we might, like Divya said, we can look at ways of incorporating it within the platform in the near future, safe harbor all over.
Great.
Yeah.
But if you're looking for a specific database load, I'm sorry, I don't know if you're from Salesforce or not, but if, let's say you're not using Salesforce, right? You need to be thinking about metrics like she pointed out, DB CPU, buffer gets, is there an app that's connected to it?
What
Is
are
that
the
gonna be an
other
impact?
things that are running, like if you have triggers or other processes that are running once a record gets inserted, if you're looking at data loading time. So once a particular record gets inserted, what other operations happen during the process of that transaction. So runtime for that particular value and how much amount of API time is being consumed, things like that.
Great, thanks.
Sure. All right, so I think we're pretty much done. We'll be posting these slides along with a lot of resources and links for you in the chatter feed a little later today. And if you have any questions, I think we'll just be on the side. Thank you so much.
Thank you.
And have a great